Hi, class. All right, we will start today's lessons. One thing I wanted to point out that I added in case you wouldn't have seen it, is under our course resources. So from our homepage to resources, up at the top here, what I've gone ahead and added was the solution to all of the textbook exercises. So this will give you all of the exercises in the book. It will give you the answers. I know that's what your homework is, but if you're working on your homework and really struggling, you can use these to help with figuring out what you might need to do. So just as another resource for you guys. I also have a book here in case you're interested in sort of the next step beyond this class, which is the actual analysis, which is mixed models in R. But that's a complete supplement. It's a very helpful book that I found if you're interested in doing the next step for your analyses. But in the meantime, we'll just be keeping to this book, and then this is the exercises to your book. All right. So now we are going to look a little bit on data cleaning. So what we will look at, we're going to add one new package today, which is going to be the janitor package. It is a very useful package that does some nice and fancy cleaning for our data sets. It has a nice function in it called clean names, which we'll get to at the end, but it does wonders in helping clean up some messy, organized data sets. If it's your own data set, then the messiness is your own fault to some degree. But if you're analyzing other data sets, it's very helpful in cleaning up how other people have set things up. Okay, so I'm going to walk us through different types of data formats that we will be discussing for this week. There is what we call sort of the wide format and the long format. And if you look at these two sort of data format structures, they are providing the exact same information. They're just providing them in two different ways. Both of them are what we would consider tidy, and both of them are what we would consider good. They're just two different ways. Some analyses will need things in one format. Some analyses might need something in the other format. So it's important to be able to transition, or how the tidyverse does it is pivot between these two different data formats. So this first one is what we call the wide format. So as you see, it produces the data in a generally wider format. In this case, with only two different measurements, it's not as obvious that it's wider versus longer. But imagine if there was, say, BP for blood pressure, measurement 1, measurement 2, measurement 3, measurement 4, measurement 5, 6, 7, etc. That's why this is called the wide format. So here, every column is a measure. And in this one, we have the long format, which is basically, if you imagine just kind of rotating this down under here, and then this kind of over here, converts the BP1 and BP2 to a column called measurement. And then another column, value, holds the actual value. So this is the measurement for blood pressure. 1 is 100. So for subject A, the first measurement is 100, the second measurement is 120. And you could have a third measurement of, say, 130. And in this format would give you BP1 is 100, BP2 is 120. And if you had a third one, BP3 would be 130, etc. And then for ID2, we take these same two measurements and then just stack them on top of each other. And then from ID3, we take these two measurements and stack them on top of each other. So now for your exam data set, I give you data for pre and post test, and well, you can take a look and determine which format is it. What format is it in? And what format do you want to convert to? You can go ahead and pause the video and take a look and download the data from the exam and take a look at it and decide whether it is in the wide or the long format. Assuming you're coming back to me, hopefully you have discovered that it is in the wide format. And you could easily, for different plotting purposes, convert it into the long format. And that allows you to graph things quite nicely. So like if you wanted this to be your X, so say for example, you would like a plot where your X is blood pressure measurement 1 versus blood pressure measurement 2, you could feed this measurement equals X and then Y equals value. If you had it in this wide format, there is not a simple way that ggplot will take this data and produce a graph that has BP1 on the left column and BP2, or sorry, BP1 on the left and BP2 on the right. You would pretty much always have to convert it to the long format to be able to do that. When there's two measurements, there doesn't look to be all of that much difference, but when they have multiple measurements like BP1, 2, 3, 4, 5, 6, 7, 8, then you can see that there becomes a very big difference between how wide your data set is versus how long your data set is between them. I tend to prefer the long data set or format, particularly when you might have different or unknowing numbers of measurements. So say, for example, for a lot of our work, we don't know how many sessions we're going to give a dog because it's going to be based off of performance, or how many days a dog might run because their performance, it might stop once their performance reaches a certain criterion. So some dogs might have 20 measurements, other dogs might have 10 measurements, other dogs might have 6 measurements. If that's the case, the wide format doesn't make a bunch of sense because you end up filling everything in with a bunch of NAs because some dogs only went to a certain number of measurements. Whereas in this format, it ends up being a lot more compact because you would just have a row for each of the measurements that you took. Switching between these two, whether you want, if there are missing measurements filled in as NAs or not, will actually be a function that we'll actually be able to work with in a second. But anyway, these are the two different data format styles, wide and long. Depending on the type of analysis, if you do like a lot of principal component analysis, then you pretty much always need the wide format. For a lot of plotting situations and a lot of mixed models and other types of regression-based analyses, you'll need the long format where you can do something where like value is my Y variable as predicted by my various sort of input or independent measurements. Okay. As you can see here, how do we actually define this? So this first data set is what creates the actual table. So a tribble is basically a simple way to tell, or is a simple way in the tidyverse package to make a data frame. If you were in standard R, you could do a data.frame and do the exact same thing. This is just a simple way to, as you can see, kind of create a table in a format that's easy to input. But there are a variety of ways of doing it. This is just a simple way to create this table, which is shown by this table down here when I just call up data frame. Now, let's say, for example, I want to pivot between the wider and the longer data formats. I can take my data, pipe it over to the command pivot longer. As you can imagine, there's also an equivalent pivot wider if we're going from long to wide. So pivot longer goes from the wide to the long format. We tell it the columns that we want to combine. We tell it what we want that column to be. So the names to measurement and the values to quote unquote value. And then we get this table. So now we have gone from our wide format to our long format, following this exact same sort of transition. Now, let's say, for example, I wanted to change things slightly. So maybe I wanted this to be measurement number, and I wanted this to be BP value. All this is going to do, it's going to do the exact same thing, but it's just going to change the column names that are being given. So the values too is going to be where are you putting the values and what do you want that column name to be. The names to is what you want your measurement or the columns that you're combining to be named to. And then the columns is you just tell it what columns you want to be combined. So this gives you a flexible way to define a variety of columns. So the calls could be numbered columns. So for example, I just wanted to do columns 2 and 3. I could do it this way. Whoops, what am I doing? And get the exact same thing. I could do it by C and name the columns. BP1. It's flexible, however, I want to refer to my columns based off of whatever your preference happens to be. Oops. This one is probably the easiest one. If you have a lot of names for your columns, then a lot of times specifying it by column numbers is a little bit easier, but it's a very flexible approach to do that. So now go ahead, take a second, pause the video. Actually, I'll just go ahead and stop the video, create a little break here for you. Go to your exam data set and see if you can pivot your wide data of the pre and post test into the long format.